Hi everyone. Today we will discuss chemical properties of amines. First chemical property is basic characters of amines. When amines undergo reaction with proton, that is H plus ion, it will form ammonium salt. As the basic strength increases, the value of Kb also increases and pKb value get decreases. Means the concentration of OH of bases increases, then the value of POH get decreases and value of pH get increases. Reason behind it is the availability of lone pair of electrons on the nitrogen atom increases and hence the basic strength of amines also increases. Similarly, the aliphatic amines are more basic than that of the aromatic amines. The basic nature in the gas phase of amines is in the order of tertiary amines are more basic than that of the secondary amines, which are more basic than that of the primary amine. But in case of aqueous phase, if the alkyl group in the amine is methyl, then the basic strength decreases is in the order of secondary amines are more basic than that of the primary, which are more basic than that of the tertiary. If alkyl group is ethyl, then the basic strength decreases is in the order of secondary amines are more basic than that of the tertiary, which are more basic than that of the primary amine. So this is your first basic character of amine as a chemical property of amines. Similarly, second chemical property of amine is acylation. Generally, amines undergo acylation in presence of acylating agent like acetyl chloride or acetic anhydride. When primary amines undergo acylation in presence of acetyl chloride or acetic anhydride, it gives substituted acetamide as a final product. But further acylation of acetamide does not take place, so that's why it is a single step reaction. Third chemical property of amine is alkylation, which is also called as a ammonolysis of amines. When ammonia reacts with alkyl halide, it forms primary amine. That primary amine further reacts with alkyl halide to form secondary amine. Secondary amine further reacts with alkyl halide to form tertiary amine, and tertiary amine further reacts with alkyl halide to form quaternary ammonium salt. The fourth and important chemical property of amine is carbylamide test, which is also called as a isocyanide test. This test is only given by the primary amine. Similarly, secondary and tertiary amine does not give any reactivity towards the carbylamide test. When primary amine reacts with chloroform in presence of excess of basic medium like NaOH or KOH, it will form foul smelling or bad smelling isocyanide as a final product. Fifth test of amine is reaction with nitrous acid, that is HNO2. When primary amine reacts with nitrous acid, it will form unstable RN2 plus as a intermediate, which undergo hydrolysis, it will form alcohol as a final product. Similarly, aromatic primary amine reacts with nitrous acid, that is NaNO2 plus HCl in presence of 0 to 5 degrees Celsius. It will form aryl diazonium chloride, which is also called as a benzene diazonium chloride. Aliphatic and aromatic secondary amines reacts with nitrous acid to give yellow colored oily nitrosamine derivative as a final product, and aliphatic tertiary amine reacts with nitrous acid to form nitroso derivatives. Similarly, aromatic tertiary amines undergoes electrophilic substitution reaction to give para-nitroso derivative. Sixth and most important test is Hinsberg test. Hinsberg reagent is also called as a benzene sulfonyl chloride. When primary amine reacts with that Hinsberg reagent, it forms water soluble or aqueous alkali soluble compound, that is RNHSO2pH. Similarly, when secondary amine, that is R2NH, reacts with Hinsberg reagent, it will form R2NSO2pH, which is insoluble in aqueous alkali. So primary amine reacts with Hinsberg reagent, gives the product which is soluble in aqueous alkali, whereas secondary amine when reacts with Hinsberg reagent, it will form same product but it is insoluble in aqueous alkali. Similarly, tertiary amines does not show any type of reactivity towards Hinsberg reagent. Seventh and last chemical property of amine is electrophilic substitution reaction. It involves again 4 reactions. First reaction is bromination. When aniline reacts with bromine in presence of organic solvent like carbon disulfide or aqueous solvent like water, it forms single product, that is 2,4,6-tribromoaniline. For monobromination, aniline undergo reaction with acetyl chloride in presence of basic medium. It first forms acetanilide as a final product, which is then undergo bromination to give para-bromoacetanilide, and followed by hydrolysis of para-bromoacetanilide gives para-bromoaniline as a final product. This is due to plus M effect of NH2 group is very higher than that of the plus M effect of NHCOCH3 group. Second electrophilic substitution reaction of amine is nitration. When aniline undergo nitration in presence of concentrated HNO3 and concentrated H2SO4, that is nitrating mixture, it forms mixture of product, that is orthonitroaniline, metanitroaniline as well as paranitroaniline. But out of which paranitroaniline is obtained as a major product, then metanitroaniline is obtained as a 47% and orthonitroaniline is obtained as only 2%, which is a minor product for the nitration. Third electrophilic substitution reaction of aniline is sulfonation. When aniline undergoes sulfonation in presence of concentrated H2SO4 as a sulfonating agent at 453 Kelvin to 473 Kelvin temperature, it first gives sulfanilic acid as a product, which exists in the dipolar ion, which is also called as a Zwitter ionic form. Last chemical property, that is electrophilic substitution reaction, which also involves Friedel-Crafts reaction. But aniline does not give any type of Friedel-Crafts reaction because of strong -M group does not give Friedel-Crafts reaction, that is alkylation as well as acylation reaction. Hence, aniline and nitrobenzene does not show any type of reactivity towards Friedel-Crafts reaction. Thank you.